Hi everyone. Yeah, we'll wait for a couple of minutes, might be 2 minutes or something, to check if someone else will also join. Then we'll start today's class. And yeah, anyone having any doubt regarding the last week's assignments or anything in impedance, or apart from the assignments, any of the topic of week 5 or previous weeks? If anyone have any doubt, please feel free to ask. We can discuss. Okay, good evening everyone to the week 5 tutorial class for the electrochemical impedance spectroscopy. Please clear anodic and cathodic reactions. Could you be specific on what you are meaning? Okay, if you have any trouble in speaking out, please put a message. Like, what did you mean by clearing the anodic and cathodic reaction? Anodic and cathodic current densities. Which portion is that? Are you talking about the assignment? So, uh, like if the reaction is written in two way or something, okay, and so anodic current density will correspond to the current density of the anodic reaction. So if it is what is the formula. I cannot directly tell you the answer, but anyway I can give you a small hint. That is, like if you have backward and forward reaction or anything, so in which direction is the anode side or the oxidation reaction happening. So that will become your the anode reaction. Then for that particular reaction only you have to find out the current density. So what is the formula for finding out the current density. So you know which parameter is to be calculated to find out the current density. So that parameter should be considered only for the anode reaction. Same way for cathode reaction. Okay, so I can give you only that much hint. So basically, you should consider only if it is having a two-way reversible reaction. Either you'll be considering only forward reaction. Could you share the formula? Current density formula is already there, right? Okay, anyway, we'll be seeing here. See, for today's this week, it's all about So if you have seen Sir's video, you will be sure. Anyway, we will be discussing today. Okay, I'll start by giving a summary of what was taught in this class. So yeah, this class going to be. I mean, for from this week onwards, for few weeks, it's going to be completely derivation. So what exactly you'll be finding out? The first one will be the side balance. Then you'll go to finding out the steady state site, that is only when DC current is passing. Then you will find out the current density for DC current. Then you will find out the current density for when AC is also passing. Yeah, so that's the set of step, right? Then after that you'll find out the impedance, right? So if theta dash is there, that will also be calculated that way. So yeah, that will be what we are seeing. So anyway, your doubt will get cleared when we are seeing today's class. Okay. Yeah, so yeah, welcome everyone to the week 5 class of the impedance. So, up to now, what all you have seen, just giving a brief idea on how this course is going. We started with the basics of the electrochemistry and what impedance is. Then you saw how what the equipment is doing, like what parameters we will give and how the equipment is giving the input, that is the AC current or AC potential, everything. There you saw what are the techniques that the instrument is using so that we get the output. So basically the Fourier transform and all you saw. After that you saw how we get the data, how do we are getting a data. So how is that data and how do we validate it? So there we saw the linear KKT, KKT and the use of equivalent electric circuit. Then after that, last class we saw how to simplify a circuit and how to find out the RP, RT, etc. So basically, we're seeing how to fit the data and how to obtain the parameters. So now, yes, so now you all are aware of how to fit the data up to them. Now, why are we trying to do EIS? Not just to get a physical significance. Yes, getting a physical significance of the process is important. Apart from that, if you want to know a reaction, we can propose a mechanism. Like you are doing EI impedance for your sensors or battery or anything, you have a reaction happening. So if you know from the impedance data, I mean using you'll get the impedance data, you can try to fit a model to the data and you can propose a model. So you can understand how many intermediate species are involved, and you can propose the mechanism by actually fitting the your proposed model with the experimental data. Okay, so that is the next part of, after getting the impedance data, that is the next thing you have to do. So yes, that's what we are going to learn in today's class. So everyone has gone through sir's this video. So if you have gone through, you will have an idea on what's actually taught last class. Are you able to see this, the slides? If anyone can tell me.
Yes.
Okay. Yeah. So just wait a second. So yes. So basically, as I told, it is about you're trying to predict the model when you have a the impedance data. So now what we're going to do is we are just in this week we're going to see how are we deriving a model for a given set of the data. Okay. Mm. Yes. So we'll start with the simplest equation. So it's a reversible reaction. A giving B plus, an electron is released, and it's a what to say, reversible reaction. So the first question is, who can tell what's the rate of such an equation? What is the rate? Okay, so for this question, I'll help. Like instead of just asking question, I'll try to solve it. Everyone can see, and from the next one, we'll make it more interactive so that you can you can also try answering so that it will be useful for you. So I think even in assignments, the questions are just simplifying. I mean, you're supposed to find out the current density, or you're supposed to find out the impedance. You're supposed to find out the AC current, etc. Okay. So we are supposed to give the rate. So what? So it's a reversible reaction. You have a forward reaction and reversible. So what should be the rate of the reaction? Will be nothing but the rate of forward reaction minus the rate of backward reaction. There's nothing but rate of forward reaction minus backward reaction. Who can tell me what's a forward reaction? It's nothing but forward reaction rate constant. Okay, into concentration. My yes, tell me.
Madam, this rate is how is it defined that it is forward minus reverse reaction? Can it not be reverse reaction minus forward? Means what is the logic behind this? That forward minus reverse.
That's how it is calculated. If you are going to, it's always like what we want is the forward reaction, right? So always that minus what can happen behind, like uh so if this is the direction of the reaction, a giving b plus e minus, so that's a rate, but here the reversible reaction is also happening, that's why we are writing minus of rb, because forward is the what, like when you're writing anything, it's something reactants giving product, right? So your reaction rate will be nothing but k
Right.
into the concentration of the reaction. So because you will have a backward reaction which is actually opposing your forward reaction, so you will write minus k into the concentration of the product. That's all. So same thing here, kf into a minus kb into the, that is rate constant of b into the concentration of b. So now the next thing is, so this is the first thing you can
Ma'am, one
expect.
doubt.
Yeah.
This reaction is oxidation or reduction? This is oxidation, no? Loss of electron.
Yes, the forward reaction is the oxidation reaction.
So, which means it is A is anode or cathode then? Anode
Uh,
or cathode?
we cannot see. This is not like that. If you have both anode reaction and see here, what is the oxidation reaction? A giving B plus E minus is the oxidation reaction. What is the
Oh,
reduction
yes.
reaction? B plus E minus giving A, the backward reaction. See, when
Okay.
anodic reaction and cathodic reactions are actually combined together, will you have an electron in that process?
No.
So basically, this is a half cell or one reaction is happening, which is actually reversible. That's it. Don't just compare that with the cathode and anode. We're
No,
talking.
ma'am, half cell also will be with like some hydrogen, standard hydrogen electrode or some reference electrode will be used, no?
Yeah.
So based on that, this is anodic or this is other reaction. Whether that can be told. That's for example, there are two reactions now.
Hmm.
Like A is giving B plus electron and C is taking electron and giving D.
Okay.
Like oxidation and reduction. Then how can we define the anodic and
Okay. See
other
this.
reaction?
See this. What is a reaction?
This is oxidation.
Oxidation. Now it's a reversible reaction, which means, now what is this reaction?
Reduction.
Is your doubt clear?
Ma'am, but which is anode and cathode? That is not clear, no?
Anode and cathode. See, basically there is an electrode on which this
Hmm.
reaction is happening, which is a
Okay.
reversible reaction.
Okay.
This is not like which is the anode or which is the cathode. If, for example, this
Sir,
same
ma'am,
as,
for understood, ma'am. For that reason only I asked the question because how we'll tell that that is anode or cathode because we have to calculate the current densities.
so yes, this is the anodic reaction.
Okay, means oxidation is anodic reaction.
Yes.
Okay. Okay, ma'am.
Okay,
Thank you.
it's clear, right? Okay. Okay. So first,
Yes, sir.
first finding out the rate. You found out the rate. Now the next question is, what if only DC current is passing through? What will be KF and KB? So you all know K is directly proportional to exponential of potential with some constant over here, right? So KFDC, that is the case where only what to say, DC current is passing. I am finding out KFDC and KRDC. So KFDC is nothing but KF naught, which is a constant, e to the power BF EDC. Is this clear? Any doubt in what I wrote? Everyone is able to follow, right? Can anyone respond? I just have a doubt of. Yeah, okay.
Yes, ma'am.
Okay. Because I thought I got disconnected or something. That's why I just confirmed. Okay. So I am considering only DC current passing. So there is no AC current. At that time, I can write the relationship as KF DC equal to KF naught into e to the power the B, that is a coefficient, into EDC. Same way, KRDC can also be written like this. So you all know what this B is. B is nothing but alpha NF by RT. So same thing here, minus 1 minus alpha NF by RT. So you got this much. Now this is the case when only DC current is passing. Now the next question is, what is the rate constant when the net current is AC plus DC? So these are the few of the like this, like basically the step you have to follow in finding out the impedance and all.
Excuse me, madam.
Yeah.
Here, KFAC is equal to KF naught. So why F naught is mentioned? Means
So
only
that is
K
K naught, same thing.
K subscript F means then not. What is the reason for keeping that not? Can we not directly put
You can directly put.
KF then e raised to b
No, what is
BF?
this? K naught is the representation for the pre-exponential factor. Basically, your Arrhenius equation. K naught e raised to minus EA by RT. So similar to that, so we had already seen in the first week. Here, when we are writing in electrochemical, it will become B into the potential, and here the pre-exponential factor is, see, that's simply a notation. So in order to distinguish between the forward and the backward reaction, I am putting it as KF naught and KR naught. Okay. Yes. Now coming to the total current. The total current when. Okay. So before that, so I found out the DC. What is KFDC and KRDC? So why did I find that? To find out IDC. What is IDC formula? Anyone?
F into the rate, F is Faraday's constant.
Yes, but don't forget there is a N into F into rate, where N
N
is
electron, number of electrons.
Yes, this is important because when, see here, you know, it is only one electron. When the number of electron changes, your equation will change. So here it's one. Make it a practice that when you study it as N into F, so that when the number of electrons involved in the reaction changes, you don't make the mistake. Okay. N into
Ma'am,
F.
that reaction BF, what we are having, no, in the reaction KFDC, KF naught e to the power BF. That BF also depends upon the number of electrons, no?
Yeah.
Okay.
It is alpha N into F by RT. So there the N is coming. Okay. So now F is there. Now what is the rate of the reaction? We have already written. So because it's only DC, I'll write it here. Because it is only DC, I'll be writing it as F into KFDC, where the KFDC is already found out at the top, Kf naught e to the power B into EDC. KFDC into concentration of A minus KRDC into concentration of B. I hope this clear. So it is easy to write. So if you are asked to find out the DC current, what you have to do? You have to find out F into rate. So in order to find out the rate, you should know the value of KFDC and KRDC, which is nothing but KF naught e to the power BF EDC and KR naught e to the power BR EDC. Now what will happen when the total current is flowing? That is AC plus DC current is passing. Okay, AC plus DC current is passing. So in this case, how will your equation be? Kf is nothing but, it will be same way, Kf naught, which is a pre-exponential factor, into e to the power Bf, same as like this. But what is the difference here? The total potential is nothing but EDC plus EAC, because both DC and AC current is passing. DC plus EAC. Now what I can do? I can split the bracket. So how will I get? It will be nothing but Kf naught e to the power Bf. I hope everyone knows how to split it when it is a bracket inside an I mean in the subscript of an exponential. You can write it as e to the power Bf EDC. Again, you can write Bf EAC. I hope this step is clear for everyone.
Right. Clear.
So after that,
Yes, it is clear.
okay. So
Yes.
what is this? Kf naught e to the power Bf EDC. The same as this one, right? KFDC. So you understand that this part is KFDC. For the first question, I'll be doing the derivation in the sense I'll be finding out what is KFDC, I mean KF total. So after this onwards, I'll be directly using the formula. I just wanted to show you how that derivation comes, just refreshing. Now this is of the form e to the power x, where I can do the Taylor series expansion. So how do you do e to the power x? It will be 1 plus x square by 2 factorial plus x cube by 3 factorial, etc., etc. So same thing goes over here. If I do the Taylor series expansion, it will become 1 plus BF EAC, and the next term will be BF EAC, the whole square by 2 factorial, and etc. Other terms will come. But you already know the ESC value itself is something in millivolt. So it is something like 10 millivolt or something. When you square it, it's become 100 milli. I mean, the are smaller than that. So values are getting smaller and smaller when you are actually squaring it or making it the cube and everything. So basically, I will avoid all the terms after this. So this can be written as KFDC into 1 plus BF EAC. Anyone has any doubt? So this is about KF. So similarly, KR will be nothing but KRDC 1 plus BR into EAC. Any doubts on this? Is this clear? No one has any doubt, right?
So BF EAC is equal to written BR EAC.
This KR.
KR.
Yeah, this KR. Where is the doubt?
Okay, right.
Okay, I'll give you 1 minute. If anyone has any doubt, just see. I'll just repeat once again what all I did. I understand this little complicated in the sense you have a lot of steps and all. So it's better if you just, for the first problem, we'll go step by step so as to understand. From next question onwards, we can speed up so that if anyone has any doubt, it'll all be clear. So the rate of first step is writing the rate of the reaction, so it is nothing but so if you have multiple steps, so again you have to include all the reactions, like if I have A giving B plus E minus, same way C giving D plus E minus, rate will nothing be but it will be, you are finding out the sum of the rate. Okay, so where the forward reaction will be taken as the positive rate and the backward reaction will be given a negative. If you have multiple reactions, same way, forward reaction positive, backward reaction negative. That's how you are finding out the rate. Next step is to find out the DC current. So you're finding out the DC current. What you need is the KFDC, KRDC, which is nothing but the pre-exponential factor into exponential raised to the B into the potential. So here only DC current is there, DC potential is passed, so it is direct BF into EDC. KRDC is nothing but KR naught E raised to the power BR EDC. And when you write the DC current, it will be nothing but F into rate, N into F into rate, here N equal to 1, and rate will be nothing but you just have to substitute KFDC and KRDC in this equation to find out the IDC. Now what happens when total current is AC plus DC? The difference will be same equation, everything is same. The only difference is in the equation of KF and KR. Unlike the last time where you only had EDC, here you will have EDC plus EAC. So you will split it, and this one will be nothing but KFDC. You will do the Taylor series expansion for this e raised to the BF into EAC. When you do that, will be 1 plus BF into EAC plus BF into EAC the whole square by 2 factorial, etc., etc. So when you're squaring it or doing any other raised to the power, that value keeps on decreasing, hence we will truncate it after the first two, that is 1 plus BF EAC. So and similarly KR, so this for the AC current. When AC current
It
is
is also called linearization, I think.
linearization. I am linearizing it using Taylor series expansion. So KR equal to KRDC into 1 plus BR into EAC. So now this much is clear, right? Now uh, I'll just add a slide. Okay. So why did I do this? Now I have to find out the IF, that is the AC current density. So which will be same formula, that is F into rate, N into F into rate, here N equal to 1. So F into, I am writing the equation once again, that is K forward reaction into concentration of A minus, someone asked me why forward, I'm giving that is one switch. So rate is always forward minus backward. If you want, you can write the other way also, but you will have to again tell that in the beginning. So always it's forward minus backward is what is conventional, and KR into B. Now what is the next step? We found out what is KF and KR when AC current is also passing, right? So I can substitute that. So what does that become? KFDC right into 1 plus B1 or BF EAC into concentration of A, okay, minus KRDC 1 plus BREAC into concentration of B. Now what do you have to find out? You have to find out the impedance. So impedance is nothing but I into Z equal to V, right? So what are we trying to do? We have to separate the, what to say, we have to get the Faraday current. So we are trying to separate the DC current and the AC current. Okay. So how do we do it? So if I am separating it, I am multiplying KF DC into each term. KF DC into 1 into A. So that becomes my first term. Okay. What is my next term? My next term is KF DC into BF into concentration of A into AAC. Basically, I'm opening the bracket and multiplying it. Now, the next term is KRDC concentration of B minus KRDC BR concentration of B EAC. Is this much clear? Now, see these terms. KFDC into A minus KRDC into B. What are these terms?
Madam, in the second term, it is KF AC or DC?
DC.
The second term. Okay.
How did I get this? First term I multiply KFDC into 1 into A. This gives me the first term, right? Next term is KFDC into BF into EAC into A. Basically, I'm opening the bracket and multiplying. Okay. Now you see this. F into KFDC into concentration of A minus KRDC into concentration of B. What is that?
IF.
IF? Which IF?
No, sorry.
What IF is it?
Faraday current.
Yeah. When? Which case is it? So what are we finding out now? The total current. That I have written as IF. So here it's total current. So we already found out one IF. What was that IF? Can you turn back and check? Only thing I'm doing is I'm just rearranging it. I'm taking both the terms and writing together. Okay. This much I'm writing as separate term. Plus again F into, I'm just separating it out and writing. Who can tell me what is this? Do you have any doubt? Is that the reason why you're not able to understand? BF into concentration of A. Just I'm writing the second term of the previous step. Okay, you can see. Who can tell me what is F into KF DC into A minus KR DC into B?
Rate.
Hmm?
Rate.
Yeah, so what is that rate multiplied by F giving? This one.
IF DC, I think.
Yes, it is IFDC. That is IFDC. See, that is correct. That's what I was looking for. See, now what I'm writing is total current. So that's the point why we have written DC current first. Our intention is to get the IFAC. So I have to separate IFDC and IFAC. So initially I found out the case when no AC current is passing out. What is it? Okay. So obviously we know anyone is having any doubt in this. So you see here, we already found out IFDC, which is F into KFDC into concentration of A minus KRDC into B. Basically, when your rate constant, KF is subscript DC. That means only when the DC current is passing, what is the rate constant? So this is nothing but IFDC. So we know that what we have written this, we started writing for total current IF. So which is nothing but the sum of DC current plus AC current, right? So if this is equal to DC, that's this full term is equal to DC, we can obviously say this the AC, this the AC. This part should be AC, right? So from the total current, I separated IF, DC and IAC. So this one equal to IAC. Now if you see, you have EAC in this one and this one. So I can take IAC out. Is this correct? I'm taking EAC out. Is this correct? Anyone having any doubt? Please stop me if you have any doubt so that I can clarify. Because your assignment is fully based on such mechanism based question.
So it is IFAC.
This one,
Like here we have written
yeah,
IFDC in.
yeah,
So
this
this will
is
be
directly
IF.
correct AC. Okay. Now what I will do? I can take this EAC this side. What is IFAC by EAC? Who can tell me? What physical quantity is IFAC by EAC? What is current by potential?
Impedance.
Yes. Is it impedance or inverse of impedance?
Inverse of impedance.
Yes. So this is nothing but 1 by Z. Okay. Which one? This. So I'll write that in the next page. So from this I find out that Z equal to, I'm just taking the inverse just to write it as okay, 1 by Z equal to F into KFDC, this BF into A minus KRDC KRDC BR concentration of B. So we get the total equation. Any doubt, anyone? So once we get the impedance equation, we can actually, so what is this impedance? This is nothing but the Faradic impedance, Z or ZF, which we are meaning. That means it's Faradic impedance. So we show, like last class I showed you how do you represent impedance, like Faradic impedance. That's nothing but you have a solution in any electrode, in an electrolyte. You'll have a solution resistance, which can be determined by a resistor. Then you have a capacitor, which will be giving the double layer, and you will have ZF. This is where the Faraday impedance is. So this can be modeled using it can be a simple Randall circuit, or it can be the Maxwell circuit, ladder circuit, etc. Now come to this equation. You can see it is just 1 by F into KFDC into BF into concentration of A minus KRDC into BR into B. So there is no what to say part of the equation which contains omega. So we are trying to now like based on the equation, we are just trying to predict what will be, how can we represent ZF. So you can see from that equation there is no omega, right? There is no omega in that equation. So there is no dependence on the frequency. Impedance is not dependent on the frequency. So if impedance is not dependent on a frequency, you do not need a capacitor or an inductor to model it. Please be understand one. I'll repeat once again. That is, if the impedance equation is not having omega, that means the impedance is not a function of frequency. That means impedance is not dependent on frequency. When the frequency changes, there is no effect on the impedance. That in such a case, you do not need a capacitor or an inductor to model the circuit. So it's all constants. I can directly say that in order to model this, I only need a resistor. No capacitor, no inductor. So this ZF will be nothing but a simple resistor. Any doubt? Are you able to get the concept of what I told at the end?
Yes.
Yes. So here it will be our solution. You will have CDL, which is parallel to here. Faraday impedance will be nothing but a simple resistor. Now if the question is to find out the total Z, what will it be? It will be the sum of, it will first be the parallel connection of this two. So that will be nothing but 1 by, what is the impedance of capacitor? What is the impedance of a capacitor? What is the formula for impedance of the capacitor?
One upon j omega c.
Yeah, j omega c. So here it is 1 by zc. So you're able to understand, right, how I'm finding z total. These both are in parallel, so I will have to do this one. And here I know zc is 1 by j omega c. So if I want to solve it, I can j omega c plus, it will be f into kfdc bf into concentration of A minus KRDC Br concentration of B. Is this clear to everyone? Any doubt?
No.
So this is the method how you have to follow to solve such question. That is, I'll just repeat once again so that like next question onwards we'll do little more fast. Okay, so what you will do first, you will find out the rate of the expression, then you will find out the DC. What are the rate constants when DC current alone is passing? You'll find out K of DC, KR DC, and then you will find out the current when DC only the DC current, that is the equation is there. You will substitute. Now we have to find out what will happen when total current is AC plus DC. So you have to find out separate equation for KF and KR when AC and DC current are together flowing. Then after that, I'll write the formula for the total current, that is NF into the total rate. From that, I'll separate IFDC and IFAC. Once I get IFAC, I can take out the EAC from that equation and I'll get the impedance. Then the impedance equation will be uh, written and you'll try to physically tell what the ZF is. Is it a resistor alone or a combination of resistor and a capacitor, or a inductor and a resistor? And you can also write the total impedance if needed, if asked in the question. So these are the things that are being taught in this particular chapter. So yeah, now the another question. So for the same equation, I'm just asking you, I have K1, K2, B2 plus what is IF DC? Who can tell?
2 into F KF, yes, K1 into concentration of A minus K2 into concentration of B.
Will be B2 plus. So here
Yes.
the yeah. So here the only difference is you have that 2. The rest all the procedure is same. So the steps are all same. The only difference is don't have to forget to put this 2. Okay, irrespective of what this value is, it will keep changing here. That's it. So if a question of this kind comes, this is how you have to proceed. Okay.
See, Lakshmi, here that we have a question in assignment, but we didn't get this option K2 into concentration of B plus 2. So only we have the option that K1 into concentration of M solution minus K2. Is that the right?
I didn't get to.
So in the assignment, we have one question on similar, same. So here you put the two concentration of A and concentration of B plus 2 plus. So in the assignment options, only one concentration is given. So with the K2, there is no concentration. So is that how we have to assume that there is no multiplication factor of this concentration?
I have to check the question. I cannot tell apart from that. And also, it's
Yeah, yeah. No, it's okay. But we have to add that concentration now.
yeah, that's how you'll write a rate equation. No,
Yes.
anything else is specified in that question, I have no idea.
Okay.
Huh.
Okay.
So yeah, now the next question. Okay. So this was the first type of problem, that is simple reaction, where a reversible reaction is happening. You have to find out. Now what happens? You have an see, why are we trying to propose a model, especially when your so like this one which you saw is a simple case. If I'm modeling it, you know all the, you everyone knows this is a simple Randall circuit. So you will get something like this. But this might not be the case. You will have multiple intermediates that are, so this what I meant is Z imaginary versus Z real. This is how the graph will come. You can predict because you know just a capacitor in parallel to resistor, you have a single loop. Now what will happen? You can get multiple loops or anything. You need to predict the mechanism. There are possibilities that more than one intermediate will be involved in that particular reaction. So in this week we are going to see only those reactions where the number of intermediates involved are one. But if you have multiple, the procedure remains the same. Okay, so this all.
Srilakshmi, sorry to interrupt you. One question. So during the EIS measurement, we have to start from higher frequency to lower, or we have to start from lower to higher
Higher to lower.
every time?
Yeah.
Okay. So okay. So if we get the EIS data from lower to higher frequency, what would be the wrong?
See, when you're starting from higher to lower frequency, what is happening? At high frequency means, you know, frequency and time are inversely related. When the frequency is high, the time is very less. So that means at high frequency, what you're actually learning is just the electrode electrolyte interface.
Okay.
When you go into lower and lower frequency, the time taken for data acquisition increases, right?
Right.
That means
Right.
you're giving enough time for the reaction to happen, or you're trying to study the reaction mechanism. So basically, the kinetics and mass transfer effects are studied in the low and the mid frequency regime.
Understood.
So
Clear.
the order should be such that you should start at frequencies where time taken is less, so that you are able to study the electrode electrolyte interface. When time is increased, when at lower and lower frequency, the time given is more, and you're trying to study the reaction happening at that interface. So
Understood.
you should start from high frequency and then go to the low frequency.
Clear. Clear.
Okay.
Thanks.
Yeah. So now we are going to study the next type of mechanism. So the first one is just a simple semicircle and no other intermediates are involved. Now we will also see a case where an intermediate is also involved. So the only difference comes is when your intermediate is involved, you have to do something known as a side balance. So here it is like M. So if you know the equations and how to write the equations, irrespective of how the question comes, it becomes easy for you. The model is same. Anything can come. So if you remember your assignment question is something, you have a reversible reaction for this kind of question. So if you know one type, the equation remains the same. Might be in one or two of the equation, you will get an extra step. Okay. Now the next step is M adsorbed. So what is this M adsorbed meaning? You have so many molecules, and when one of these molecules are exposed to electrolyte, it has the tendency to give out the electron. Okay, what does it make them? This becomes some. Okay, so these are all the molecules, the metal, or the metals, you can consider all this as M. So when it's exposed in the electrolyte, some molecule will have the tendency to give out an electron, knock off the electron. This state where it has not gone out of the metal surface, but it has only given out an electron. It is still staying in the surface, but it has given out an electron. That is a M-adsorb. Now, after some time, what happens is it will leave a vacancy. Okay, underlying there will be another metal electron. This will be under, not on the on that surface. It's something on the below line. So that electron has gone. This M adsorb goes out into the solution. So that becomes M solution. So you should understand M adsorbed is here corresponding to that particular molecule which has given out its electron, but stays on the surface. Then once it goes into the solution, I tell it's M solution plus, and it is able to what to say, expose the metals, which is metal, what to say, that the next metal, which is metal atom, which is underneath the that which has gone out. Okay, so that's a process happening. Now, first step to understand is you have to identify which is the electrochemical step and the chemical step. Who can tell me what is an electrochemical step and what is a chemical step? Who can tell me which is an electrochemical step? And who can tell me what is a chemical step? Anyone? Any idea?
No idea.
Okay. So, as the name suggests, chemical step means any step in which chemical reaction is happening. So, I'll name this as 1 and 2. Okay. So, electrochemical step means where there is a reaction happening with the loose or gain of an electron. Electrochemical means a reaction is taking place along with an electron transfer. So, which one is electrochemical step? Is it the first one, second one, or both of them? A reaction which involves transfer of electron. That is an electrochemical step.
First one.
Yes, the first one is a
First,
electrochemical step.
first one is electrochemical.
Yes. Second one is just a chemical step because there is no electron transfer happening. It's just a chemical step. Now, why is this important? When you get, there can be chances where you will have multiple steps. Identifying electrochemical and chemical steps are important. Why? Because you have a current passing through. You write what is the formula? General, I'm just writing it as IF, not DC or AC, just IF. There is nothing but N into F into rate. When is a current flow happening in a system? We are discussing about a electrochemical cell. So where reaction is happening because of the transfer of electron, right? Is there any doubt? Be it for any reaction, a battery or anything, when does a current happen? When there is a flow of electron from anode to cathode or cathode to anode or anything, right? So here in this IF, the when you're writing the current density, the rate corresponds to the sum of the rate of the electrochemical step only. You cannot take into consideration all the step. Sum of the rate of the electrochemical step, I'm just writing as EC. So what does that mean? In this case, IF is so current in the Faraday current is contributed by which all reaction steps?
Electrochemical step.
That means only the first reaction. So here when you're
First.
writing the rate, that will be just for this step. You shouldn't write the it as a sum of even the second reaction. Please keep this in mind. That's why I showed you what is an electrochemical step and chemical step. Because when the flow of current happens in an electrochemical cell setup only when there is a flow of electrons. And in this case, the flow of electrons happens only in the first reaction. Hence, the current is contributed by the first reaction only. Please keep that in mind. So that's the first thing. But when you are writing, when you have intermediates involved, you will write the side balance. Side balance in the sense you have a set of, so That's what you have, a set of atoms on the set of atoms. If I visualize the my metal as set of atoms, what happens? One atom can lose an electron and can get charged with, so, and then it leaves the solution. Okay, so so if I'm saying, when it leaves a solution into the solution, when M absorbed is leaving, it is leaving a gap. In that gap, the atom below that is getting exposed, right? So if I'm saying theta as the fraction of sites which are occupied by the M adsorbed plus, what is the fraction of site occupied by the metal? Are you able to understand? So what did I say? There is a metal surface. Okay, so on the surface of which there are atoms like this. Now below also, below this there will be another layer of atoms. So they're stacked one over the other. Okay, when this loses an electron, this becomes M adsorbed. M ADS means M adsorbed, which will then later on at the next step it is moving to the M solution. It's moving to solution, it becomes M solution plus. So when it moves into the solution, what is happening? It is leaving that place. There is a gap created, right? When that gap is created, what happened? There is a set of atoms below also. There's something of this form. When this leaving here, there is a gap, and the atom below, there will be another atom which will be exposed. Okay, so if I'm saying that the fraction of sites, there will be multiple atoms at one time itself, multiple atoms will be forming, will be losing electron or getting charged. So the fraction of sites which are occupied by M adsorbed I can say as theta, while the rest of the site where the metal is occupying I can say as 1 minus theta. Is that clear to everyone?
Yes.
So now we'll start deriving that equation. So I'll write once again, and yes. So the equation was M. Everyone can start doing. First thing is to do the side balance. Who can tell me what's a side balance? How to write the side balance? So the first step is to write the side balance. The first question is to write the side balance. If I say the total number of sites is theta and the change in sites occupied by M adsorbed over time, I can balance it like gamma into d theta by dt, which is equal to, who can tell me? So over time, how is the fractional occupancy of M adsorbed changing? So you know both the reactions are forward reactions, right? So when first reaction happens,
It is K1 1 minus theta minus K2 theta.
yes, correct. reaction, so the side, this what to say, the side balance will be sum of all the sides. So it's only for finding out the current that I have to take into consideration the electrochemical step and the chemical step. When it comes to finding out the side balance, I should take into consideration all the reactions which are involved. Okay, now see what is happening in the reactions. You can see that the first reaction is only forward reaction. So when time is passing, what is happening? More and more of theta is getting formed. So more and more of 1 minus theta is, so if theta is the fractional occupancy of MHF, 1 minus theta is the occupancy of the metal atoms. So when the reaction is happening, it is K1 into 1 minus theta. So by which the number of sites are actually increasing. The sites occupied by MHF are increasing when the forward reaction is happening. Now what is happening in the next reaction? M adsorbed is changing to M solution. That means the adsorbed sites or the theta sites are actually getting reduced over time. That is why I will write minus of K2 theta. Is the step clear?
Yes.
So understand the significance. Don't try to learn it by heart. Understand what's happening so that you can write it as such. That is, in the step I'm trying to do the side balance. So in the first reaction, as time is passing, what is happening? M is forming, M adsorbed. That is, the theta concentration keeps on increasing. So it will be the positive of K1 into 1 minus theta. While in the next step, it is the M adsorbed getting continuously consumed. That is, the theta is reducing. So theta reduces over time, it will be nothing but minus of K2 into theta. That's why we are writing minus. Okay, so this is the first step. Now the next step is you have to find out what is theta at steady state. Theta at steady state means what? What does that mean? There is no change of theta over time. Theta is a constant. At any instant, that theta value will be a constant. When will that happen? The formation of theta, so that means d theta by dt equal to 0. That is, there is no change in the theta
Right.
value over time. So that means what? The formation of theta in reaction 1 equal to the consumption of theta. That is, how many theta sites are formed in the first step? Equivalent number of M adsorbed is losing into the solution to, and the site is becoming vacant. Okay. So if I am writing this, I can write it as K1 into 1 minus. So this time, okay, at steady state, what happens? It's only the DC current that's passing. There's no AC. So K1 DC 1 minus theta S is minus. Yes. Now the next thing. One more thing. Electrochemical step is somewhere the electron is removed or electron is gained or something like that. So this step, it is dependent on the K1 is dependent upon the DC or AC. There is a current flow, but here this step is independent of current, right? So here this will always be a constant. K2 is always a constant because there is no electron transfer involved. So I can write K1 as K1 DC in case of steady current, otherwise I can write as K1 AC. I mean, K1 is a function of DC and AC, but K2 will be a constant. I don't have to write a superscript, I mean subscript for K2. Is that clear? Why it is K1 DC and K2 is as such? Is it clear?
Okay.
Yeah. So these are the small mistakes you can make. K2 is a constant, but in a question, if you are given K1, you have to find out K1. You will have to multiply by. I mean, if it is K1, you are supposed to find out that K1. It will be nothing but it will be K1 DC into 1 plus B1 EAC, right? But this same time K2 won't be something which is dependent upon the potential. It is just K2. If you are asked to find out the numerical value, just be careful. What is K1? What is K2? Now, what is theta SS? Who can tell me what is theta SS?
It is steady state fractional
K,
surface.
K1 dc upon K1 dc plus K2.
Yes, what I asked was the formula. What you told is correct. You had to tell me the formula. Okay. So you found out. So sorry. Now the next thing is you have to find out. So theta SS is found. Now what you have to do is you have to find out IFDC. Please find out IFDC and tell me.
Madam, please show the previous slide. Just I couldn't write that. Okay.
So everyone can write IFDC and let me know once you write it. I'll just give couple of minutes. If anyone finishes before that, you can tell me. Okay. Yes, who can tell me? What is IFDC? F. Okay.
Into then we have to write that K1 dc
Hmm.
bracket 1 minus theta.
Hmm. So when DC current is passing, see what is formed is getting. I mean, how much ever mH sub is formed, that's the equal amount it is getting. What is converted into the solution? So that will be 1 minus theta SS. So if you are asked to find out IFDC, you should first find out theta SS, substitute it into this and simplify. Who can now tell me the simplified version? Please substitute the theta SS value and tell me. What is the equation?
F K1 DC in the bracket K2 upon K1 DC.
K2 upon?
K1 DC
Is it only K1 DC?
plus K2
Yeah. Don't make a
plus
mistake, because
K2.
if you are supposed to find out the numerical value, you will get a wrong answer. Okay. Yes. So you have found out IFDC. So now the next thing you have to find out is the total current. So what is the total current? IF equal to? Who can tell me? Please try and then let me know. What will be the difference? Here, for the same equation, you will have to find out what is K1, which will have K1 DC as well as EAC term coming in that. Okay. Same way, what will be K2? Will there be a change in K2? Because it's a chemical step. When it's total current, what are the equations? First write that down and then substitute it in IF, where IF will be same thing, F into rate. N will be 1. Please find out K1, K2, and then substitute it in the equation. So here K1 will be nothing but K1 DC into 1 plus V1 EAC. And K2 will be K2 itself because it's a chemical step. So you all know only the first reaction is contributing to the rate, because the second one is a chemical step. Substitute what is the K1 equation and then find out. Who can tell me the equation? Please tell me. F into anyone? You're able to hear me, right?
Yes, ma'am.
Yeah, so
Yes.
someone can tell me, that's okay. It will be nothing but rate will be nothing but only the first step is contributing, which is K1 into M, right? So you know that only the first step is contributing. So which is nothing but K1 into M. So I mean here how it is written, K1 into 1 minus theta. So for this reaction, because AC and DC current are there, we can write K1 in terms of K1 DC 1 plus V1 EAC into 1 minus theta. Is this clear? Or anyone has any doubt?
Clear.
Yeah. Then why are you not answering? Someone should answer. Only then the class becomes interesting. See, if anyone knows, please do answer, because some people might have doubt. That's why keeping quiet. But when you ask questions or when you clarify your doubt, you might be sometimes helping other person also. Okay. So yeah. So you have to finally get the IFAC out, right? IFDC is already known. It is F into K1 DC into 1 minus theta axis. And you can see another term. So when only DC current is passed, you can express that in terms of theta axis. Now you have theta, which is a variable. So the next step is how to express theta, which again a formula kind. So I'll just show you how to derive it. So theta, I'm just doing the Taylor series expansion, that is theta SS, which is already known. Okay, plus how do you do the Taylor series expansion? It will be nothing but dou theta by dou E when a small current, so the constant potential here is EDC, right? What is the change in theta when a small potential is applied, which is DC, into delta E? So this delta E is nothing but is like that fixed potential above, and you give a small amplitude, so there is a variation. So this delta E I can consider that as EAC, and this dou theta by dou E I will write, plus there will be another terms, that is dou theta E the theta by dou E the whole square into delta E, like that there will be many. So but obviously I told you, when you're squaring it or in the cube, it will become smaller and smaller. I'll truncate with this. So this I can write it as theta SS plus theta dash, which is dou theta by dou E into EAC. Is this clear? Is this clear, everyone?
Yes.
Okay.
Yes.
So this is the another equation which you should know. So like K1 and K2 here, which is wrote as, I always like DC rate constant for the DC into 1 plus B into AC potential. Same way, this equation is also going to remain the same. So now your next step is to, what you have to do is substitute this that is theta value, okay, in this equation. Please please do along with me so that even if you make a mistake, you will understand. Anyway, you'll have to solve the will have to do this exercise. Only then you will be able to solve the assignment question. So it is better you work out with me. It will be helpful for you if you have any doubt. And try to do the assignment today itself after the class so that you won't forget whatever is taught. I'm sure that the assignments are based on similar kind of questions. Given DC B1 1 minus theta. Theta is nothing but 1 minus theta SS minus theta dash EFC. The theta dash is nothing but dou theta by dou E. Now what is the next step? Who can tell me what's the next step? What's the next step? So what do you have to do? I have to find,
We have to come out with the d by d theta.
yeah, d by d theta is left. But before that, I just wanted to separate IF DC and IF DE, right? So that's the equation which we want, right? So I'll separate. So if you see, if I'm doing this, what will I get? I'm just multiplying K1 DC, opening the bracket, K1 DC into 1 minus theta SS. Right? 1 minus theta SS, that is nothing but K1 DC into 1 minus theta SS. I'm taking 1 minus theta SS together. Okay? That's the first term. Now the next one is K1 DC into 1 into minus theta dash EAC minus K1 DC theta dash EAC. Right? Now my next term is K1 DC into B1 EAC into 1 minus theta SS. Right? Now what is the next term? K1 DC into 1 minus DC, sorry, K1 DC into B1 EAC, after which I'll multiply with the next term, which is theta dash EAC. So K1 DC, B1 EAC into theta dash EAC, you see EAC square will come. So I told you squaring these values, the value is going to reduce even more. Okay? So that term is neglected because the value is going to be very small. So when I am expanding this, you will have only 3 terms. Any doubt in this?
Clear.
Yeah. So yeah, I forgot to, no one told me, I forgot to put F.
Yes.
So if you see the first term, K1 DC into 1 minus theta SS into this F. What is that? That is IF DC. K1 DC 1 minus theta SS into F. This much is IF DC. So what is IF AC? IF AC is nothing but, I'm taking this K1 DC also out. It's common in everything, right? So what will be left? I'll have b1 1 minus theta ss, the last term. You see, EAC term is also common. So I can take a K1 DC outside and EAC also outside. And from this term, I'll have minus theta dash. So what all I'll have outside? F into K1 DC into EAC. Is this much clear? Any doubt? So if you see, this term is nothing but IAC. Anyone has any doubt on this slide, or else I'll change? So all we did is we just opened the bracket and rearranged it, found out IAC. As someone told before, now the next step is to find out theta dash. So to find out the theta dash, what we'll do is, who can tell me how to find out theta dash? How to find out theta dash? Anyone can tell? Someone respond. I hope everyone has gone through sir's video, right? Like, when is your last day for this submission of week 5 assignment?
Tomorrow.
So you should know, right? Only then you can answer those questions. Now, the next step is, or if you're thinking it might go wrong, that's okay. I can help you in correcting, right? It's better to make mistake now so that no one makes mistake in the assignments.
Right.
So the next step is to find out theta dash, which is nothing but dou theta by dou e. So
Yes.
what I am writing is dou theta by dou t equal to dou theta by dou e into dou e by dou t. This basically mathematics. I've just written that as two separate steps. D theta by dt is nothing but dou theta by dou e into dou e by dou t. Okay, differentiation. So it's this dou theta by dou e that we want, which is theta dash.
Right.
Now what is e? E is nothing but this is sum of the potential. E dc plus EAC. There again, you know, EDC is a constant, it won't change, right? It's a constant potential. Now EAC is nothing but EAC naught sine omega t, or I can write that as, in terms of polar coordinate, I can write it as EAC naught. We have seen this in the first module, first week lecture. EAC naught j e exponential raised to e j omega t. So if I am differentiating this, that is dou e by dou t, which I want. I'll differentiate this with respect to dou t. So what will be dou by dou t of E dc? What is dou E dc by dou t t?
It's a constant.
So it will be 0.
Zero.
Yes.
Right.
What will be the next term? EAC naught is a constant. So it is differentiating only e to the power j omega t. What will I get?
J omega t.
Or j omega t divided by
It will be
k omega.
j omega into e to the power j omega t. T won't be written outside. T is the
Right.
variable. J
Yes.
omega
Yes.
t is here.
Right.
So now if I see EAC naught into e to the power j omega t is nothing but EAC. If I multiply this, right? So I can write this as same thing. EAC is nothing but EAC naught e raised to j omega t. So I'm just combining this, writing it as EAC. So dE by dt is nothing but j omega EAC. Okay. So dou t theta by dou t is nothing but theta dash j omega EAC. Again, all this you don't have to do each time. You just have to learn all this by heart. Which all you can learn, which won't change. If K1, K2 is all electrochemical step, it will be nothing but K1 DC into 1 plus B1 EAC. All those you can learn by heart. Again, the next thing you can learn by heart is what is dou theta by dou t. Another thing that you can learn by heart is, I mean, you don't have to do it each time. That's what I'm meaning. So one more thing is there, right? No, these two. It won't change irrespective of whatever your equation is. This won't change, so you can learn this by heart. Now how to find out this theta dash? We are doing this to find out theta dash and substitute in IAC, then your work is done. So how to find out theta dash? What we did is dou theta by dou t. Why are we finding out dou theta by dou t? Because we can substitute this in the first equation we have learned. Which is the first equation we learned? This one. Gamma dou theta by dou t equal to the rate. Okay, so I'm substituting in that. That is gamma dou theta by dou t, which is nothing but theta dash j omega EAC equal to k1 into 1 minus theta. What is k1? K1 is nothing but you have to everything that you have learned, you have to put it here. Yes, something else that you can learn by heart is theta. Theta is nothing but theta ss plus theta dash EAC. So these three you just have to learn by heart. Each time you don't have to derive. Okay. So here K1 DC 1 plus B1 EAC okay. In that substitute one you add it out.
Ma'am, you
Yeah,
have not e to the power j omega t. Where is it gone?
I didn't get you. What did you ask?
In the here theta dash j omega e ac that is written. Along with this, it would not come e to the power j omega t. We have just differentiated, but
Yeah.
e to the power j omega t is not written.
See, you see this EAC not e to the power j omega t. What is that? It's equal to EAC.
Yes.
EAC equal to EAC naught. What is EAC naught? It's nothing but the amplitude. EAC naught e to the power j omega t. Basically, I substituted it back. EAC is just that AC potential. Amplitude of the AC potential is EAC naught. Okay. I hope your doubt is clear. So k1 into
Okay.
1 minus theta. So again, I'm directly substitute because of lack of time, not writing each and every step. So I'm write 1 minus theta. I can write this 1 minus theta ss minus theta dash EAC. Right? Now what is the next one? Minus k2 theta. You know k2 doesn't vary. It's a constant because it's a chemical step. So k2 into theta ss plus theta dash EAC. Now what has to be done? Now things are simple. What you have to do? You have to open the bracket. Please do it, only then you will understand when you will make the mistake. Otherwise, it will be difficult for you to solve the assignments. I'm just multiplying k1 dc into 1 into 1 minus theta ss. I'll always consider 1 minus theta ss together. 1 minus theta ss. Okay. The next one is k1 dc into 1 into theta dash EAC minus k1 dc b1 EAC. I'm sorry. I'm multiplying k1 into 1 into theta dash EAC. EAC. Okay. Now, next one will be K1 DC. Next one is K1 DC into B1 EAC into 1 minus theta SS. Now, what will happen if I multiply K1 DC into B1 EAC into theta dash EAC? You can see EAC into EAC square will come. So, I don't want that term. So, this one will get cut. Okay. This term is not considered because EAC square will come. Now, the next one is K2 theta SS. That's direct, right? Now, there's nothing else. Minus k2 theta dash EAC. Now, see, you want to balance the left side with RHS, LHS with RHS. So here you can see it is a function of EAC. Okay. So LHS will be equal to RHS only if the RHS will also be a function of EAC. Is that correct?
Yes.
That what I said makes sense, right? So all those terms on the RHS, which is just constants, can be cut. It will be equal to 0. The first term will be 0.
Okay.
Are you able to understand why?
It is not a function of EAC. That is why.
Because left side is a function of EAC. So all the terms on RHS which is a constant can be cut off. So this term will also get cut. So now what you have to do? I have 3 terms on RHS, of which the second one and the last one is a function of theta dash. Here also there is a term which is a function of theta dash. I can club them all together. EAC is common. So now when I cut all those terms, you can see left side term has EAC, right side terms are also having EAC. So again, I can cut off EAC from all those terms. Is that clear?
Yes, clear.
So this EAC, sorry, because I cut off all those terms which are having constants. So now this EAC is something which is there in this term, and this term, and this term. I'm cutting off all. Okay. Now what I have to do? I have to take theta dash terms to the left side. So this one will go that side. K1 DC theta dash will go that side. K2 theta dash will also go this side. So this side I'll have only K1 DC B1 into 1 minus theta SS. So if I club all the terms which are having K1 theta dash together and I divide it, how will I get? Theta dash will be nothing but K1 DC B1 1 minus theta SS gamma j omega plus K2 plus K1 DC. Is this clear? Is this clear? Now what you will do? You can substitute it back in IF equation. What is IF? F into, this is IF equation, this one. F into K1 DC, this last one which I have marked as what to say, red color, this one. F into K1 DC B1 into 1 minus theta SS minus theta dash. So here you will substitute the value for theta dash and into EAC, so which I am taking this side. This will be nothing but 1 by impedance. So this is how you will get the impedance equation. Is this clear, everyone?
Yes, Lakshmi. So to expand it more, we have to put the theta SS value here.
Yeah, if you want, but that will make it look more complicated. You can keep theta as such, you substitute theta dash value, and you can, I mean, here you will be only doing MCQ based or problem based. So in case they have given the simplified form, you will have to substitute theta's value and simplify it more. It depends
So
on
in
you.
in the assignment they have not mentioned the theta SS.
Hmm.
So we have to put the value of theta SS
You'll have to
K1
calculate the value of theta as if it's not given.
K1 DC and then formula that last
It
PPT.
depends
Then
on, no, theta SS value changes with respect to the question. Don't get confused. Theta SS value, how do you find out? You do the side balance. You write the side balance, equate the side balance to 0. That is how you find out theta SS. Theta SS value changes with respect to the question.
yes, so for this question that you have solved, so theta SS is K1 DC upon this one.
Yeah.
So yeah, that I understood. That I understood. Clear.
Now we'll do one more. I'll give a homework kind. We'll start a question and you can try if you can do it. Okay. So unlike the one with Sir has discussed, this is a three-step mechanism. But you're having only one intermediate. One. So we'll start doing it. Next class we'll discuss on this. Please try doing it. I mean, this is a good exercise for you. Then the first step, the M adsorbed is formed. Next step is this M adsorb.
That gives M solution plus K2.
See, mechanism can be anything. Anyone can predict, okay? Some people can make any of these steps reversible or anything, okay? So I'm just giving you an example where this is the equation. Where the third step, M is directly forming solution. I mean, it is directly going into the solution. That intermediate formation is not happening. Now, in this case, the first question is, who can tell me what is theta SS? Since we are running out of time, I'll just give you 2 minutes. So to find out theta SS, what we should do? We should do the side balance. So how do we do the side balance? Gamma d theta by dt. What is it? Someone can tell?
K1 1 minus theta minus K2 theta.
Then only that much? Only that much? Is there nothing happening in third step?
Yes, electron is there. Electrochemistry is
So
clear.
for side balance, you have to consider all the reaction. There is nothing like the electron transfer or not. For side balance is basically considering what is the sites available.
Clear.
Okay, side balance is considering only the sites involved. That means if you see in the first step, what is happening, M is forming M adsorbed. That is the metal is getting consumed. So metal occupancy is 1 minus theta. So K1 into 1 minus theta. The next one, sorry, the M adsorbed is formed in the first step. So positive of K1 into 1 minus theta. The next one, the M adsorbed or the intermediate is consumed. So minus K2 into theta. Third step, again the metal is consumed, okay, directly. So when metal is consumed, again there is a vacancy, I mean that occupancy is again changing, okay. So this is a side balance. Now how do we find out the theta SS? Can anyone tell me? How to find out theta SS?
To put the theta by dt equal to 0.
Yes, we'll equate this to 0.
Okay.
So how do we get? So what will K1, K2, K3 and all become? It is nothing but, okay, first tell me which are the electrochemical step and which are the chemical step.
First and third is electrochemical steps.
So in those two, it will be K1 and K2 is a function of the potential, but K2 will be a constant. right? So always when you get that, please identify the electrochemical step and the chemical step first. So now if I am applying theta SS, how will it be? K1 dc 1 minus theta SS minus K2 into theta SS plus K3 into 1 minus theta SS equal to 0. Now when I equate it to 0, rearrange it, you will get what is theta SS. Okay, you will have to find out. I'll ask in the next question to someone. Please do it. Okay. Then after this, what is the next thing to find out? IFDC. How to find out IFDC? Tell me. What will be the equation? Anyone?
Theta SS will be K1 DC plus K3 divided by K1 DC plus K2 plus K3.
Yes, correct. That's correct. So, yeah. So now the next thing. What is IFDC? How will they find out IFDC? It will be F into rate. Which all equation will be involved? First and the third one, right? Because second one does not have electron transfer. So here it will be K1 into 1 minus K1 DC into 1 minus theta SS, and here it will be K3 into 1 minus theta SS, right? Now what you have to do? You have to substitute the value of theta SS and simplify it. Okay, then you will get the answer for what is IFDC. Okay, that will give you the simplified answer. Again, we'll discuss that in the next class. Now the next thing is to find out IF. So how do we find out IF? IF will be same thing, but it will be F into K1 into 1 minus theta. So K1 I can write it as K1 DC into 1 plus B1 EAC 1 minus theta. How can I write 1 minus theta SS minus theta dash EAC? Is this correct? Are you able to follow? Is it correct? Are you able to follow? This K1, this 1 minus theta. Now the next term will be K3 DC 1 plus B3 EAC. One minus theta SS minus theta dash EAC. Same thing. Okay. Any doubt in this? Then you have to substitute the value of theta dash. Before that, you have to find out what is IFAC. Basically, you should remove the IFDC, you will get IFAC. Then you will find theta dash. Then you will substitute back and you will get Z equation. Is that clear? Everyone, anyway, try this. We will discuss this as the first question for our next session, because next week also what you're going to learn is the same thing. I mean, week 6, instead of one intermediate, you will be learning how to solve when you have two intermediates. So please get this thorough. Only then you will be able to do it when you have two multiple equations to be solved simultaneously. Is it clear? Any doubt? Was there any doubt for anyone?
No, it's okay.
It's okay. Anyone has anything, please tell me. If not, we'll wind up today's class. I know it is basically you're deriving an equation, so you should know step by step. Only then it will be easy to solve. Okay, the steps remain the same. If you get the concepts thorough, irrespective of however the equation comes, it will be easy for you to solve. Basically, you'll start with the side balance, equate it to 0. You'll find out theta SS. Then you'll find out IFDC. Then you will find out IFAC. For that, you will have to substitute theta dash in that equation. Again, K1 and K2 will be in terms of EAC. Again, you will substitute that, you will find out IF. Then you will get the Z equation. That's all the thing is to be done. The steps remain the same. All you have to do is you have to know how to do step by step. Okay?
Madam, in the last assignment, which assignment number 4, which is already solved and submitted all everybody. So they have given answer also, but sometimes we do not come to know that how they have solved it.
Okay.
So suppose the 15th and 16th question in the last. So they have mentioned RT is 25 ohm and RP is 60 ohm, but
Okay, we can discuss that in the next class then. 15th and 16th
okay,
question.
yes, 15th and 16th.
Okay, we'll discuss it in the next class. Okay?
Okay.
Okay, then that's all for today. Good night, everyone. We'll meet next week. We'll discuss that question next week. Okay. Thank you.
Thanks,
Okay, thank you.